All right. Hello, Algebra. Good morning. Welcome back. All right. We are going to talk about multiplying polynomials. So we had been working with quadratics, and on Friday/Thursday of last week, you looked at see which or what different forms of quadratics help us find which things. So, for example, we saw vertex forms help us find the vertex, factored form helps us find the x-intercepts, and standard form helps us find the y-intercepts. Now, all of these different forms are helpful with finding specific things, but if I have one form and I'm looking for a different thing, they don't really help us that much. So it's important for us to be able to transfer from one quadratic form to another quadratic form to easily help us distinguish which of those features do we have available, which of those features can we find easily from our equation. So we're going to talk about something called multiplying polynomials today. And this is going to help us be able to transfer from one term to another term to another term and so on. But we're going to start off with this warm-up that you had today. So your warm-up was to multiply 6x times 4x to the third. Now, this is really just simplifying expressions, simplifying exponents like we were working with earlier this year, because I see that this x is really an x to the 1. And I know that when I multiply exponents, or when I multiply numbers that have of the same base and different exponents, that I add my exponents together. So x to the 1 times x to the third is going to give me x to the fourth. And then my coefficients for both of these numbers are just going to be treated as normal. So 6 times 4 is going to give me 24. So this is going to be 24 x to the fourth. What if we look at the second problem? You didn't have this as a warm-up. Let's look at this. So we have two quantity 3x squared minus 4x plus 5. So if I have this 2 outside my parentheses, thinking back to the very beginning of the year, we know that if we have a number outside of parentheses, we can distribute it to help simplify. So that means we have to multiply by everything inside the parentheses. So you take that number, you multiply by each term inside those parentheses, and that will help us simplify. So 2 times 3x is going to give me, or 2 times 3x squared is going to be 6x squared. 2 times negative 4x is going to give me negative 8x. And then 2 times 5 is going to give me positive 10. So it'd be 6x squared minus 8x plus 10. None of this is going to simplify because we have an x squared, an x, and a constant. So they're all different terms. So that would be our final solution. So both of these pieces of information are going to be helpful for us later today, with our multiplying polynomials. So let's start off by talking about what does it mean to be a polynomial. So polynomial, the word breaks down into two pieces: poly and nomials. Poly, that first prefix of our word poly means multiple. Like a polygon has multiple sides, or when you're playing in Desmos and you have those polygraph, you have multiple graphs to choose from. So poly, that prefix means multiple. Nomial, our second half of our word nomial, this means terms. So when we look at a term of a quadrant, or if we go back to this last problem, we have three separate terms in our problem. I have my first term, my second term, and my third term. A term is a list of variables and numbers that are combined through addition and subtraction. So this is one term, this is a second term, this is a third term. So it can be any sort of list of numbers and variables combined through addition and subtraction. So what polynomial means, it's multiple terms. So for example, this would be an example of a polynomial because it has multiple terms. This would be an example of a monomial because it only has a single term. Mono means one. So polynomial, monomial. So when we're multiplying polynomials, we're multiplying expressions that have multiple terms in them together. So for example, looking down here, this equation is two polynomials. I have one term, two terms, so it's a polynomial. I have one term, two terms, so I'm multiplying two polynomials together, and I want to see what the result is. So that's what we're going to jump into today. Let's start off by looking at this graph. So we're going to graph in Desmos x plus 1 times x minus 3. So if I pull up this graph, here's my equation. I want to look at my x-intercepts of this graph. So what we noticed on Friday/Thursday of last week is that in factored form, my quadratic, when it's those two parentheses, that factor form, my x-intercepts are always going to be the opposite of the numbers that show up. So if I have a positive 1, I'm going to have a negative 1 as my x-intercept. If I have a negative 3, I'm going to have a positive 3 as my x-intercept. So I can easily find my x-intercepts from that point. And that's something we should have noticed about our factor form on Thursday/Friday of last week. So that's our basic quadratic based off where those x-intercepts are. -1, 0, and 3, 0. So we're gonna try to multiply these polynomials together, and we'll show you how to do that. We're gonna multiply these polynomials, and then we're gonna see if anything changes about this function, if anything changes after we multiply the polynomials, or whether things are different at all. So we have two ways of multiplying polynomials. We have the distributive property, which you're pretty familiar with, and then we have this area model, which I'll introduce, or known as the box method. So the distributive property is we have another way of memorizing it called FOIL. And what FOIL stands for is first, outer, inner, and last. First, outer, inner, last. That's what FOIL stands for. And what this is telling us is this is telling us how we distribute when we have binomials. So when I am multiplying, typically when I am doing distributive property, just like what we did at the very beginning, we take that single term and you multiply it by everything inside. We multiply everything inside of parentheses. Now, if I'm multiplying these two polynomials together, I have two terms that I need to multiply by two terms. So I have to take this first term, multiply it by everything. I have to take the second term, multiply it by everything. To help us tell which ones to do. So first in FOIL, we have first. So that means you're going to take the first two terms of each of our polynomials and we're going to multiply them together. So that's going to be x times x. So what is x times x? That's just x squared. Outer means I'm going to take the most outside points of my polynomial. I'm going to multiply them together. So that's going to be x times -3. Well, what's x times -3? That's just going to be -3x. Inner stands for I'm going to multiply my inside polynomials together. So that's going to be 1 and x. So 1 times x is just going to give me positive 1x. And then last means I'm going to multiply the last terms of each of my polynomials together. So 1 times -3 is going to give me just -3. Now, I messed up because I wrote down -3, but I didn't write down -3x. So I need to put my x in there. I apologize because this should have been x times -3 is -3x. But now looking at my terms here, I have 4 terms that I got, but 2 of them are like terms. This -3x and this 1x, these are both like terms. They both have a single variable of x in them. It's just x to the power of 1. So I can combine these. So I would have x squared left over from my top. -3x plus 1x is going to give me -2x. And then I have just -3. Now, none of these are like terms anymore, so I know this is simplified. I have an x squared, a -2x, and a -3. So that would be simplified. Another way that we can do this is called the box method. So the box method is you make this little 4-squared box as shown on the board. You can just easily draw like a little X or a little T to make it for you. And then on the outside of each of our boxes, we are going to put one of our terms of our polynomials. So for example, I have x plus 1 and x minus 3. So x plus 1 and x minus 3, I'm writing on the outside. And now all we need to do, we know the area of a shape, the area of a square, the area of a rectangle is just length times width. It's one side times the other side. So if I want to find the area of this, I would just take one of my variables times, or one of my terms times the other term, and that'll give me my area of my shape. So that's why this is called the area model as well. So x times x is really just x squared, and I'm going to write that answer in there. X times -3, if I multiply these two rows together, x times -3 is going to give me -3x. If I looked at these rows and multiply these rows together, x times 1 is going to give me 1x. And then lastly, my last corner over here, I have 1 times -3 is going to give me -3. Now, if I look, once again, these two terms both have an x in them, so I can combine them. So I know my x squared doesn't have any terms that are similar, so I'm just going to leave that as x squared. My single x's negative, or my positive 1x and negative 3x, those can be combined once again, and those are going to give me negative 2x if I combine them. And then my negative 3, once again, it doesn't have any terms, so it's just going to be negative 3. So if you look, both of our answers are the same. Both of these methods will get you the same solution. It's just two different ways of doing the same style problem. Now let's graph this new equation and let's see if we see anything different about it. So graphing this equation. So this was my original function. My x plus 1 equals x minus 3. Now if I graph my new function, x squared minus 2x minus 3, let's see if anything changes. Nope. All we're doing is we're just graphing the exact same line over top of our original one. If we look, our x-intercepts are even the same, negative 1 and positive 3. Exactly the same. So what we can do is when we multiply these two polynomials together, we aren't changing the function at all. We're actually keeping the function exactly the same. We're just writing in a different form. So if we remember back to Thursday, Friday, this new equation that we have, this is in standard form, while our original is in factored form. So we can take a factored form polynomial, multiply them together, and get our standard form. We can actually see, thinking about our standard form equations, that our y-intercept is always that last term. So in this case, our y-intercept is going to be negative 3. Let's keep looking and see another example of this. So I have the polynomial 3x squared minus 2 times 4x squared plus 7. I want to multiply these together and figure out what the standard form equation looks like. So once again, FOIL tells me to do first, outer, inner, last. So let's do those multiplications. First terms multiplied together is going to be 3x times 4x. So 3 times 4 is 12. X times x is 12 squared. Outer says negative, or 3x times positive 7x. So 3 times 7 is 21, and then I have a single x value. Inner means I have to take my inner term. So negative 2 times 4x. Negative 2 times 4 is going to give me negative 8, and then I have an x term. And then lastly, negative 2 times 7 is going to be 14. Now, if you do this right, your middle term should always be the ones that should simplify together. Your middle terms of your 4 terms, if you're doing two-term polynomials. If we do it correctly, those two should be the ones that should go together. Sorry, my thing disappeared. So if we look at this, we have 21x and negative 8x. If we combine 21 and negative 8, we should get, let's see, 21 minus 8 should give us 13x. So that should give us positive 13x. 12x squared doesn't have any like terms, so it's going to come down as just normal 12x squared. And then 14 doesn't have any like terms, so it's going to come down as just normal. So we have 12x squared plus 13x plus 14. So I know this is going to be my standard form equation. And I can easily see that I know my y-intercept of this equation is just going to be 0, 14. Once again, we could use this box method if you want to see this method again. So all we have to do is just write our terms on the outside. So 3x and negative 2, and then 4x and 7. And we should get the same idea for our solution. If we multiply the insides of these, so 3x times 4x is going to be 12x squared. 3x times 7 is going to give me 21x. 4x times negative 2 is going to give me negative 8x. And then negative 2 times 7 is going to give me negative 14. And I realize I just messed that up on the first one. Negative 2 times 7 should be negative 14. I wrote down positive 14. I apologize. So that's a minus. And then that should be a minus as well. But once again, just with our box method, we can simplify these by adding these together. So I have 12x squared, which doesn't have any like terms with my other terms. So I'm going to write 12x squared down. My negative 8x and my 21x are both like terms. So we can combine those to get me a positive 13x. And then my negative 14, which has a weird line in it, should just be negative 14. Once again, when we're writing these polynomials, we always want to write what's called in standard form is highest power to lowest power. So if you look, I have x squared, x, and then no x's. X squared, x, then no x's. So it's always going from highest power to lowest power. So if we had x to the 5th, we'd put x to the 5th first, and then to the 4th, and then to the 3rd, and to the 2nd, and to the 1, and then to the 0. So you always write from highest power to lowest power. It's just typical math notation. Mathematicians like it that way. It just looks organized more. It's not incorrect if you do it the other way. It just doesn't look as organized. All right, what about this weird equation? X minus 2 quantity squared. So can I simplify this in any way? X minus 2 quantity squared? Well, if we think about this, we know when we have a number squared, it's the same as writing it multiply, or it's the same as that number being multiplied by itself. So x minus 2 quantity squared is the same as x minus 2 times x minus 2. And this I know I can factor, or this I know I can FOIL together, first, outer, inner, last. So I'd multiply my first terms, x times x is just x squared. Multiply my outside terms, x times negative 2 is negative 2x. Multiply my inner terms, negative 2 times x is again negative 2x. And then my last terms is negative 2 times negative 2, which is going to give me a positive 4 because it's double negatives. Once again, my two inner middle terms should be the ones I simplify after this. So x squared is going to come down because it doesn't have any like terms. There's no other squareds. Negative 2x and negative 2x can combine to give me negative 4x. And then I just have a simple positive 4. And that would be my simplified fraction. So I can see, I know based off my factor form that this should be my x-intercepts. I'm going to have an x-intercept at 2, 0 based off my factor form. And I know based off my standard form that my y-intercept is going to be at 0, 4. That's my y-intercept. So we can easily see from factor form and standard form are two different pieces. Once again, you could use your box method on this. You just have to write x, negative 2, and x, negative 2 for your boxes. And we could easily get what all those four pieces of our box are, and then add those together. All right, let's look at one last one. Now, this polynomial is a little bit bigger. So we have 2x minus 3 times 3x squared plus 4x plus 7. So I have what's known as a binomial. Binomial is because it's a polynomial with only two terms multiplied with a trinomial. It's tri because it's three terms. If we think bi, like bicycle, you have two wheels, and a tricycle has three wheels. A binomial has two terms. A trinomial has three terms. But they're all still polynomials because they have multiple terms. But we can still multiply this. So just like with our distributive property, just like with FOILing, we have to multiply the first term by every single term in my second polynomial, and I have to multiply my third term by every single term in my second polynomial. Or we can use the box method, and the box method works for this one as well. I'll do both. Let's do both. We have enough time. So we're going to take 2x and we're going to multiply it by 3x squared, 2x times 4x, and then 2x times 7. Let's do that part first. Let's just get that out of the way first. So 2x times 3x squared is going to give me 2 times 3 is 6. X times x squared is going to give me x to the third power, because I know I add those exponents together. 2x times 4x is going to give me 2 times 4 is positive 8. X times x is going to give me x squared. 2x times 7, 2 times 7 is going to give me 14, and then x is, there's just 1, so it's just going to be single x. So that was from my first multiplication. Now I need to do my second term. I'm going to multiply negative 3 by everything in my second equation, or my second polynomial. So it's going to be negative 3 times 3x squared, negative 3 times 4x, and negative 3 times 7. I need to combine all of these together. So negative 3 times 3x squared, I'm going to actually write this below. Technically, I should keep going, but I want to give myself enough space. So negative 3 times negative 3x squared is going to give me negative 9x squared. Negative 3 times 4x is going to give me negative 12x. And then negative 3 times 7 is going to give me negative 21. So technically, all of these terms are being combined together. I just wrote them in two separate spots so I have enough space. But if I look, what terms are what? I'm going to start with my highest powers, and I'm going to look to see if I have any like terms. So do I have any like terms with 6x to the third? So 6x to the third is actually my only power to x to the third. So I'm going to write that down as in my answer first. Now I'm going to look, do I have any x squareds? Well, I actually do have that. I have 8x squared and negative 9x squared. So I'm going to combine these together. So 8x squared plus negative 9x squared is going to give me negative 1x squared. Next, I'm going to look at my single x values. What single x's do I have? Well, I have a 14 to the x. I have 14x, and then I have negative 12x. positive 14x plus negative 12x is going to give me positive 2x. And then lastly, I have negative 21. Now, negative 21, there's no other constant term, so negative 21 is just going to stay the same as, sorry, that should be x there. It's just a single negative 21. So we still combined all our like terms, and we should, in this case, we're actually having a 4-term polynomial left over. 6x to the third minus 1x squared plus 2x minus 21 is our final solution. So this would be our answer of our binomial times our trinomial. Once again, we could even do this with our box method. I just need to write my two terms, 2x and negative 3, and then I need to write my trinomial on top. So I have 3x squared plus 4x and then plus 7. And once again, all I have to do is multiply all these areas together and then combine my like terms. So 2x times 3x squared is going to give me 6x to the third. 2x times 4x is going to give me 8x squared. And then 2x times 7 is going to give me 14x. Going down to my lower part, I have 3x squared times negative 3, which is going to give me negative 9x squared. Negative 3 times 4x is going to give me negative 12x. And then negative 3 times 7 is going to give me negative 21. Now, a nice little trick about these box methods, when you have multiple polynomials, multiplying them together, the diagonals are always going to combine. So if I look at these diagonals going left to right, kind of diagonals, will always combine. So I know that 6x to the third doesn't have any diagonal, so it's going to just stay as 6x to the third. Negative 9x squared, or negative 9x squared and 8x squared are combined together, so those can give me negative 1x squared. Negative 12x and 14x are combined together, so those can give me positive 2x. And then negative 21 doesn't have any diagonals, so it's going to stay the same as well. So 6x to the third minus 1x squared plus 2x minus 21 is my final solution once again. So this is multiplying polynomials. You are going to have a little bit of practice over this where you can have some time to ask questions, get some help over multiplying polynomials, look at some problems. And then you are going to do an activity where you're going to look for some shortcuts. So there's certain types of polynomials, there's certain types of binomials that we can multiply together that can create shortcuts. And as you can recognize those shortcuts, it makes this very, very fast because without having to do any of this stuff, any of this work up here, you can just easily write down the answer right away. And in the future, we can use the shortcuts to work backwards, which makes doing the stuff in the future much, much faster if you can recognize them. So we're going to look at this activity that's going to teach us a few shortcuts that you'll kind of figure out with a little exploration. So you are going to be very good at multiplying polynomials by the end of the period. Let me know if you have any questions. Other than that, have a great rest of your day.